Hey guys, how you all are doing? Today finally we're gonna start with electron microscopy, which is a good thing for me and I'm hoping that a good thing for you as well. But if it's not, mention your good thing that happened to you today. It could be you had a good meal or you're gonna meet today, maybe somebody today, or maybe you're gonna go party, or maybe something or the other. Any good thing that happened to you today or gonna happen to you today, just mention in the comment section. For that, let's get started with electron microscopy. But again, as one of our ritual, we're gonna see the electron microscope. Of course, it's different over here. We are having some kind of other equipments along with the screen. Now, why is that happening? Because this time we are using electrons, not the light. So we need to ensure the electron do not hit any other kind of air molecules. Okay, because we know when electron will hit air molecule, they'll collide and they'll scatter. But what we want electron to hit only our specimen. So we are using specimen on all other equipments which are ensuring to get the high resolution. So finally, let's see the principle now. See here, we are using electrons. Why are we using electron first in the place? You all know that resolution becomes more better with the decrease of wavelength. As long as we're using more short wavelength, resolution is becoming more and more better. The reason has been discussed in the initial videos of the series. Now, wavelength of electron is about 1 lakh times shorter than of visible light rays. Now, can you imagine the resolution then? It is much higher than light rays that are giving. It is around 1000 times better than light microscope. Why? Because the wavelength is only about 1 lakh times more shorter. And finally, so when we are having high resolution, that means points as close as 0.5 nanometer can now be distinguished, and the useful magnification that we are getting is again 1 lakh times. I'm not talking about the magnification, I'm talking about the useful magnification, which is 1 lakh times. You can appreciate the resolution given by light microscope and electron microscope. Here we are having the 3D image, the beauty of electron microscopes. Here you can see it's all blurred. Can you make out anything? I can't. Okay. I hope you also cannot make out anything other than it's a blurred image. Here you are having a 3D image with a high resolution. Here we are having cavities. Here we are having lining the tissues, and we can make out most of it, the external structure we can make out, right? So that is the power of electron microscope. Now the thing over here is we're gonna talk about two type of electron microscope on the basis of how the images are forming. These images are forming, of course, by electrons, but how are we using those electrons to form the image? See, if the electrons are passing through the specimen, then it forms transmission because they are getting transmitted through the specimen. Clear? But what if those electrons hit the specimen and specimen produce their own secondary electrons? Then it is called scanning electron microscope. The scanning electron microscope will become more clear in the next videos, when we'll be talking about scanning electron microscope. But this video we're going to talk about transmission electron microscope. We will be talking about the image production by the passing of electron through specimen. So now let's see the parts of transmission electron microscope. See, first we are having electron gun. It is a mandatory one. Why? Because we are supposed to use electron. So what this electron gun will be producing? A beam of electron. Condenser lenses, make sure that you never use condenser lens as I now used. Do not. Why? Because condenser lenses are the lens that will not allow the electron to pass through them, because as you know, electrons cannot pass through lenses. So what we are using condenser lenses, we are using electromagnets as condensers. We are not using condenser lenses because because electrons cannot pass through lenses. Again, the function is just same, helps in focusing the beam. You know that when electron gun will be producing a beam, it will be blunt. Okay, but what we want, a specific focused beam onto the specimen, and that is a function done by condensers, those electromagnets. Okay, these will be producing a focused beam onto the specimen. Then we are having specimen which is specially stained, we're talking about staining of all the specimens under light microscope, confocal microscope, electron microscope in in staining series. But the thing is, these are specially stained. These are not stained as light microscope specimen. Okay. The next thing is objective lenses. These are again electromagnets, but ensure that we do not use objective lens. These are objectives, okay? Because again, electron cannot pass through objective lenses, but work same as objective lens. They're using because what we want, those electrons coming from the specimen get focused onto the screen, and that is the function of objective lens, right? Finally, we're having the fluorescent screen, the different screen to get the image coming, basically to collect data from electrons and then to make it onto the screen, on the fluorescent screen. But as I told you, we are gonna use vacuum chamber. Electron gun, condensers, everything is placed in vacuum chamber because we do not want electrons to hit any other air molecule or any other dust particle, because then they will be not efficient in producing the image. Finally, let's see the parts again. We are having the electron source or the electron gun. We are not gonna say condenser lenses. We're gonna say condensers, which are electromagnets. Then we are having the specimen. This beam of light get focused onto the specimen with the help of condensers. And then finally we are having objectives, the electromagnets again. These objectives will ensure that these collect the electrons and magnify the specimen. And finally we'll be having the fluorescent screen. Now these kind of parts, the intermediate stage and projector lenses, these are the kind of parts that are accessory, not necessary. Okay, so these kind of parts can be there or cannot be there, but the basic parts are the parts that we talked about. These kind of lenses or kind of intermediate stage and all will be ensuring that better images are produced. Okay, again you can see here electron gun, a beam is produced which is blunt but get focused by the condensers. Then we are having specimen, then of course objective lenses, and finally we are having the fluorescent screen which is getting all the electrons. Okay, finally the working of transmission electron microscope. As I always say, if you are having the principle clear in your mind and the parts, working of any microscope is just a piece of cake. See, when we'll be switching on the electron gun or the electron microscope, electron gun will start producing the beam of electron. Why? Because what is electron gun? It is a tungsten filament which will get heated and produces a beam of electron. These beam then will be focused onto the specimen through condensers, and then these specimen can either scatter through the specimen, or they can pass through the specimen. I'm repeating it again. When electron beam is focused onto the specimen, specimen can either scatter the electrons or it can allow some of the electrons to pass through it. So when the scattered electrons, when we are having some scattered electrons from the specimen, those are of course not hitting objective lens, so they are getting lost. No image formation from scattered electrons. But those electrons that pass through the specimen, they will now pass through objective lens. And finally, we are having the enlarged image of the specimen on the fluorescent screen. But wait, who will scatter and who will allow the electrons? See, those denser regions scatter more electrons, and we will be getting those regions as dark images because only fewer electrons hit the screen. As I told you, scatter electrons will not help us in forming the image. They are scattered, they are not received by the objective lens. So denser region will scatter more electrons and fewer electrons hit the screen, so those regions will appear dark in the images and are called as electron dense region. And those less dense, or we can say electron transparent region, will allow the electron to pass through them, and so they will appear brighter because those electrons that are passing through the electron transmission transparent region are received by objective lenses. Finally, images are produced on fluorescent screen and are seen. See, there's a difference. These are produced on fluorescent. The images are produced on fluorescent screen, but they are seen on the photographic film or on the laptop screen. And since we are getting the images on the laptop screen or any kind of maybe the computer screen, those can be permanently recorded. So finally, now you know that we are getting the image by using the electrons or the radiation passing through the specimen. This thing will become more clear when we'll be talking about scanning electron microscope. Okay. So finally, we are having this, the last part, the working. See, we are having electron gun. It is getting passed through condenser lenses, specimen, hitting the specimen, and objective lenses. I think there's some sort of confusion that objective lenses are placed before the specimen or after the specimen. Make sure you note this point. Objective lenses are placed in such a way that they are receiving the data coming from the specimen. See now, light microscope, do not look at this point. Okay, light microscope having the electron or having the lamp, those microscope that we talked about were having the lamp on the downside. Okay, so these light rays were hitting the specimen and those objective lens were placed here. They are getting the data from the specimen. Here we having the transmission electron microscope whose electron gun, or maybe the, you can say in lame language, the light source is over here, and so the electrons are hitting the specimen in this direction. So objective lenses are supposed to be placed here. So objective lenses are placed in such a direction that they're receiving the data coming from specimen, coming from the specimen. These both are specimen. So these are receiving the data coming from the specimen. Finally, we are having image on the fluorescent screen. We can either have ocular lenses or we can have, the photographic films on the laptop screen. This is the last image because I really want this thing to be clear in your mind. That's why I'm using so many images. I'm so sorry if that's getting irritated or something or getting repeated again and again. But I really want this thing to be clear in your mind that we are having electron gun, the high voltage, then the condenser, it is required to focus that beam. And then finally we're having specimen, your objective lenses. There can be 2 or 3 electro objective lenses because to make high efficient images. Then finally we are having the, what do you call it, fluorescent screen. These all are electron beam coming from the objective lens. And finally there will be a photographic film as we seen on the first slide, the electron, where we'll be getting all the what do you call it, the final image to be seen. So with that, guys, I'm so thankful for you to hear me out, and I'm waiting for all the good things that you're gonna mention in the comment section. I'll be starting with mine. With that, thank you so much. Like, share, and subscribe, and you can follow me on Insta or on YouTube to get the regular updates from the microbiology videos. Bye bye. Take care.